Hi, so today I want to show you how you can multiply and divide rational expression. Okay, so let's just jump right into the examples because it's just like multiplying two fractions together. You multiply the top and you multiply the bottom. Okay, so suppose I have 5x squared plus 25x divided by 2, and I want to multiply by the following fraction, 4 divided by 6x plus 30. Okay, and again, the trick here is just you multiply the top and you multiply the bottom together. Okay, so this is equal 5x squared plus 25x. All of this multiplies to 4 divided by 2 times 6x plus 30. Now, I just make a very classic mistake there. What I did was I make a distributive mistake, right? So in order to multiply this through, you need to put the parenthesis around 6x plus 30, right? Because you want to distribute that 2 into every single term of that binomial. Okay, so what do I see? I see the 2 and the 4 cancel, right? That's left me 2 up here, right? What else I can do? I can factor out the top and I can factor out the bottom, right? So for the top, I can factor out 5x. After I factor out 5x, I have x plus 5, right? And then I'm gonna just bring that 2 down here, right? Divided by, and the bottom I can factor out the 6, right? 6 times, what's left is x plus 5. And wow, look at that. We can cancel some more, right? We can cancel x plus 5 on the top with the x plus 5 in the bottom. So now my fraction is 5x times 2 divided by 6. And one more time, we can cancel the 2 and the 6. So the final answer will be 5x over 3. Okay, so that's multiplying two rational expressions together. Now let me show you and remind you how we can divide rational expression. That's a little bit more important. Okay, so suppose we have A over B divided by C over D. Do you remember how this is done? When we divide fraction, we inverse multiply, right? So we're gonna keep the first fraction, so A over B. However, for the second fraction, we're gonna flip it. So you wanna multiply, so multiply D over C. Okay, so for second fraction, we're gonna flip multiply or inverse multiply, okay? Now, do we ever flip the left fraction? Do we ever flip A over B? No, we don't ever flip the first fraction, right? We only flip the second fraction and then we multiply. Okay. Okay, so let's take a look at the example to illustrate the point. If I have x squared plus x, all of this divided by 5, divided by xy plus y over 25. And again, we flip the second fraction, right? So this is equal to x squared plus x divided by 5, just rewriting the first fraction, multiply 25 divided by xy plus y. Okay, so let's factor out everything and then we cancel all at once at the end. Okay, so this is equal, the top, I see I can factor out the x, right? I can factor out the x, that's left me x times x plus 1, right, times 25 divided by the bottom 5 times, I can factor out the y on the bottom, so y, and that's left me x plus 1. Okay, and now we can cancel some term. I can cancel the x plus 1 and x plus 1, right? And I can cancel the 25 with the 5 here, so that's left me the 5 on the top. So the final answer will be 5x over y. Of course, y cannot be 0. Okay. Maybe on the top here is good because we have 3 in the bottom, and 3's always stay 3. Okay. Okay, so let's take a look at another example, a bit more involved, okay, a bit more complicated. So suppose I have a squared plus 3a plus 2, all of that divided by a squared plus 5a plus 4. And I want to divide it by the following fraction. A squared plus 5a plus 6 divided by a squared plus 10a plus 24. And again, in flip multiply, right? So this is equal. For the first fraction, I'm going to leave it like that. A squared plus 3a plus 2 divided by a squared plus 5a plus 4. Now multiply, we'll flip the second fraction. Now the bottom becomes the top, so a squared plus 10a plus 24 divided by a squared plus 5a plus 6. And now I can factor, right? Let's see. A squared plus 3a plus 2, both positive, both is same size. So I want 2 number. When they multiply, I get 2, and then we add up, I get 3. So 2 and 1 sound like a good combo to me, right? Because 2 times 1 is 2, and 2 plus 1 is 3. Okay. So the bottom, same thing, right? Both positive, both same size. So I want 2 number. When I multiply, get me 4, and I add up, get 5. So 4 and 1 sounds good to me. Right. Okay, second fraction. A squared plus 10a plus 24. So I want to find 2 numbers when I multiply to give 24, and then when I add to give 10. Right. 6 and 4 sounds like a good combo to me, right? And 4. And the bottom, a squared plus 5a plus 6. Again, same size, same positive. So I want 2 number. When I multiply, get me 6, and when I add up, get me 5. So 2 and 3 sounds good to me. Okay, so what else? Let's see, I can simplify. I can simplify a plus 4 here, right? A plus 2, and a plus 1, right? So what's left is, what do I have left? Is a plus 6 divided by a plus 3. Okay, and then of course, a cannot be -3. Why? Because the bottom will be 0, and we don't want that, right? Okay, so that's how we multiply and divide rational expression. Thank you for watching.